All right, so let's find the coordinates of this point P on the unit circle here. Now, the circle is showing an angle in standard position of 60 degrees. So we can just find the side lengths of this triangle in order to find the coordinates x and y, right? Because the short leg of this triangle, this is a 30, 60, 90 triangle, and we've looked at 30, 60, 90 triangles in the past. The short leg of the 30, 60, 90 triangle here is the x coordinates, the horizontal leg. The vertical leg is the y coordinate. And then if we can figure out the legs of this triangle, then we can find the coordinates of the point P. All right, so if you recall, let's draw a 30, 60, 90 triangle. Let's make it, let's see, like that. Let's make, oof, I can't draw a straight line. Let's draw a straight line if I can. All right, let's draw a 30, 60, 90 triangle. All right, so this is 60 degrees. And our standard triangle, we had 1, 2, square root 3. Okay? Now, if the hypotenuse is 1, all we really need to do is just scale this triangle down by a factor of a half, right? If we multiply everything by a half or divide everything by 2, we'll have a similar triangle, and then we'll have the triangle that matches the triangle that's shown on this unit circle, right? Because the radius is 1, so I want the hypotenuse to be 1. If I divide it by 2, I'll get 1. And if I divide these others by 2, I'll get what I want, right? I'm just scaling it down. I'm just scaling that triangle down by a factor of 1/2, okay? So then this is 1. And so you can see now that the x coordinate is a half, right? This is going to be 1/2, and this is going to be, the y coordinate is going to be the square root 3 over 2. And so that means that the cosine of 60 degrees is 1/2. And the sine is the square root 3 over 2. All right? All right, let's take a look at the next one. All right, let's go ahead and do example 4 as well. Because it's very similar. It's just that now we have an angle in the second quadrant, right? So we have an angle in the second quadrant. It's 120 degrees. So now we want to find the coordinates of this point. But you can see I just dropped a perpendicular line down to the horizontal axis, and we can see a triangle there, right? So now I know that an angle over here would be 180 degrees. If I go halfway around the circle, I'm at 180 degrees. But this angle is not quite all the way to 180 degrees, right? It's 120 degrees. So I know that I'm 60 degrees shy of 180. So this angle right here is 60 degrees. The angle that's in the triangle that I can see here, right? I can figure that out because those two angles have to add to 180 degrees. So we basically have the same triangle. It's just that we're in the second quadrant where the x is negative and the y is positive. So just like before, this x value here is going to be, the side length is a half, but it's negative because we're in the second quadrant. So this is going to be a negative 1/2. And then the y here is going to be, now it's positive, right? So the y value is positive, but the length is a square root 3 over 2. So you can see the x and y coordinates are basically the same, except the x is negative. All right, so the cosine of 120 degrees is a negative 1/2 because we're in the second quadrant. Cosine is negative in the second quadrant, right? Because the x coordinate is negative in the second quadrant. And the y coordinate is the square root of 3 over 2. It's positive, right? We're in the second quadrant. So the y value is still positive. All right, it's easy as that. So next thing we're going to talk about is reference angles. And you'll see that these reference angles are handy for figuring out the coordinates of these special angles, like the 30 and the 60 and the 45-degree angles, because the reference angle gives you the angle that is in the triangle. All right, so we'll talk about that next. I'll see you in the next video.